Hello everyone, how are you doing? In this video, we'll talk about the second most used statement in a database right after a select statement. It is a join. And a join is used to connect two tables. So far we have had only one table, but in this video we'll create a second one and we'll start connecting the information from one table to information in the other table. And the join needs two things. So it needs a type of join that you want to use, and we'll do that in a second, and it needs join criteria. So basically one column or more columns that you want to connect the tables on. And I think it makes sense that we start this video by a short introduction, theoretical introduction to the types of joins that we have. And by the way, don't worry, if this will not make much sense so far, after this introduction, we'll jump right into the code and we'll spend much more time explaining how things work. So first off, what we have is a left join. And the left join requires two tables as every join. We have the left table and the right table in a join. So the left table, in a left join, when we do a left join, all the rows that are returned are all rows from the left table plus the information from the right table where the join condition was successful. So where we found a matching information, right? So if you have some data in the left table and then you have a column which you use to join, if the values from this column from the left table are found in the right table, the rows from the right table will also be returned. Otherwise, they will not be returned. And if you return some columns from this table and the values don't match, they will just have a null value. Now we also have a right join, and the right join is nothing else as a left join, but the other way around. Works exactly the same. All rows from the right table plus only matching rows for the columns returned from the left table. It is a very small difference. I sometimes even would put this into just one category, because if you see in a second in syntax, if you just change the way it's written or change the place that the tables take, essentially right join becomes a left join and the other way around. So this is a right join. Next type of join, this is an inner join. And an inner join will return only values from both of the tables where there are values in the columns that you used to connect these tables on. So if you say used a column ID from a left table and a column ID from the right table, there needs to be the same value in the ID column in the left table and in the right table for the row to be returned. So the ID column needs to have the same value for a particular row in the left table and in the right table. And then the fourth type of join is a full join. So in a full join, we return essentially three groups of rows. First group of rows is a group of rows that is only found in the left table. Then we have a group of rows that's essentially the inner join, so this part in the middle here, that these are the rows where the values in the join condition or join criteria are found in the left and in the right table. So this is the inner join. And then we have a right join part, or not exactly right join part, but we also have the third group, which are the rows from the right table, where the values in the join condition column were not found in the left table. Okay, so this was our short introduction. Once again, don't worry if so far this does not make much sense. In my opinion, these Venn diagrams are a suboptimal way to present it, and the best way to present it and the best way to really learn it is just to run few dozens or few hundreds join statements, and then you start to really understand it and it becomes very, very simple. Okay, with that being said, let's jump right to SQL now. Okay, so here we are in our SQL developer, and before we start, we'll once again need to update and create some new tables in our database. And the procedure is the same. In the description, you have a linked file you just copy the contents of the file, paste it into your worksheet here, and run the whole script. Here I have the file. I'll just copy everything, paste it into the worksheet here, run the script. And now if I refresh, the two tables here should be created, the countries table and the people table. Okay, let's remove everything and let's start working on our joins. So let's first try to select what we already know how to do. Let's select name, surname, and then the country from people table. So now what we can see here, that additionally to the people that we had in the previous episode, here we have Mr. Johnny Smith, who's from Denmark. And now let's say that to all the people that we have here, we want to add the currency that they use. And the currency information we have in our countries table. Let's now take a short look in our countries table. Here we have the name of the country, the area that it covers, and the currency. So what we want to do is we want to take all the rows from the people table and we want to add their currency. And this should link you to the left join explanation, right? We take all rows from one table or to right join. All rows from one table, from the people table, and we join the rows from the countries table. So let's do that currently. We select name, surname, country from people, and we do a left join countries. And now we say on, and this is very important. When I say that it selects all rows from the people table and returns the matching rows from the countries table, what I really do mean is what we say after the on column. So here we will now set like a join equation, join conditions, that if true, will join the two tables together horizontally. So basically we say on, and now here we have the name column that holds the name of the country. And in the people table, we have the country column, which holds the name of the country. So we need to say on country equals name. But if I run this now, we'll get an error. And the error is because there is a name column which is ambiguously defined, meaning the column is in both tables. Therefore, we have to use the table names in front of the columns to let our interpreter know, okay, from which table I should take the name column. And it should take it here from the people table, and it should take it here in the join criteria from the countries table. If I run it now, nothing changed. And it's because we now need to add the currency column in our list of columns. And I need to add our name table, just so that I actually don't need to add it, but just so that we see that it's the same as the country here. And now what we can see is what we wanted. We have all the people here and we have their currencies, with one exception. We have Mr. Johnny Smith, who's from Denmark, who has null in the name _1. So basically the name that comes from the countries. It's a good practice, I would say, to define an alias in such case. So we say countries name, right? So that it's clear that it's a name that's coming from the countries column or countries table. However, for Denmark, if we take a look at our countries, we have no currency. Therefore, we have a null. So essentially null is a no value. And this is basically exactly how a left join works. So we really took all the rows from the people table and we returned here the matching rows from the countries table. So not all the rows, and we returned only the matching ones, right? So here, if Mr. Johnny Smith, or to be more precise, in Denmark, has no entry in the countries table, here we get the null values next to Mr. Johnny Smith. However, currently the query has gotten a little bit long because we had to repeat the names of the columns many times. So what you can do is you can define aliases as you do for columns with a slightly different syntax, because you don't say as P as an alias, but you just say P. I will say P for people and then C for countries. And now instead of saying countries, 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 and countries once again, I can see that just C dot, C dot, C dot, and here I can just say P. and I can run it once again. This will work. So now let's try to take a look at this from a different perspective. Let's try to start from our, maybe I will delete it totally. Let's try to start from our, once again, countries table. And now let's try to select or assign to every country the people that come from this country, right? So we start from a different direction. And I will just leave this asterisk here just so that you see what happens if we leave an asterisk here. So we say select start from countries, and now we do a left join with people on, and let's define the aliases from the very beginning. Basically on c dot, and now we say name, right, equals to p dot country. So essentially the join criteria are the same. And I just run it. And now what you can see is that we have it a little bit different. So we have all the rows from the countries table, but what's maybe surprising are two things. First off, we have more rows now than we have in the countries table, because here we have only 5 and here we have 10 rows. So basically what has happened is we have more matches for a particular value than one. So for example, we have 3 people from Germany, not 1. Therefore, every time there is a match, there is a new row created and added to our result set, right? Because here we have Germany and Mr. or Miss Penelope Smith comes from Germany. Here we have Clayton, who comes from Germany, and here we have Sebastian, who comes from Germany. Therefore, we have more rows in the result dataset than we have in the countries table. And once again, we have these nulls here. And this is because France does not have anyone who comes from France in our result set. So basically here we have these nulls. One more observation. We put the star here, and the star means that we just wanted to return all the columns. Now you can see that we have many columns here. And this is why also you want to be careful with using stars, because the result set can get pretty big very quickly. There's one more trick you can do. You can just say c.star. This will return you all the rows from countries. And now you can say, for example, comma, I don't know, p.name. And this will return you all the rows from the C or from the countries table and only the name from the people table. You can just as well do p and then here just say c.currency. This will return you all the columns from people table and the currency column from the countries table. Okay, so now let's maybe stick to it and discuss now how a where clause works, because you can as well here apply a where clause. So essentially what you say is where, and I will say your condition. So let's say where country equals Germany. And just as last time, from the result of the join, we selected only the rows where country equals Germany, right? Country column is only in the people table, therefore we do not have to use an alias, but we can. And I often do use aliases, even if it's not necessary, if I start using aliases in some of the columns, just so that it's clear where a column is coming from. Once again, I run it, I run a whole statement, and we have only rows from Germany. Now, this is not the only place that you can apply your conditions. You can also go in here, and just as well as you can join on columns, you can join also on constant values. So basically, here you might think that adding a where condition or an additional condition is a good idea. So let's do it. Let's say p.country equals Germany. And here it may be a surprise to you, but what we can see now is something that I think we would not expect normally, because what has happened is currently only the country Germany has got matches, and any other country that is not Germany did not have or does not have a match. So here you can see that only where the country is Germany, the rows matched. Otherwise, the rows did not match, and therefore here we have a lot of null values. So you have to be very careful where do you place your where conditions, because once again, just to show you the difference, if I just said where here, we will have nice free rows and not the big number of rows where we have the null values. So now that this is clear, I would like to shortly remove this part, remove the condition here, return to this example, but let's select something. Let's not select everything. Let's select the name here, name p.surname, maybe p.country, then here c.name, and then c.currency. Okay, let's run this. And once again, we have all the people, and so we have here we have all the countries, and we are matching people. Let's change that. So we'll be selecting all the people, and we'll be matching to it countries. Let's run this. And now you can see the difference. We have all the people here, and we only have matching countries. Okay, but already you have seen in the change that I made that we, for a split second, we had it the other way around. So we had all countries, and here we had nulls. So essentially, if we want to go from left join to right join, this is the change that we may need to do. So let's test it first. I just change a left join to right join. Let's see what happens. And the result is exactly what we discussed. So basically here we have now all the countries, of course, more entries for every country if there are more people, but France does not have any entry, therefore it has nulls here, right? So this is the difference that we have currently. We are either taking all the rows from the people table and only matching rows from the countries, or we are taking all the rows from the countries table and only where the values of the country or the name of the country are matching, there we are taking the tuple values. So this is why I often say that it's very simple, or the difference between left and right joins for me is very small, because what I need to do to change the logic of this query from left join to right join, I can of course change the left to right, but I can also change the order of the columns of the tables here, and this will give me the exact same result. You can see it exactly the same here, exactly the same here. So this is why I often say that left and right join basically the same thing, depending just on how you order your tables. So let's remove everything here, and now let's talk about the inner join. Because the inner join is actually different, what the inner join does is it returns the rows only if the values match. So we'll no longer have the nulls, at least that's our expectation, but we only have the nice matches. Therefore, let's select the same thing we selected. Name, surname, and then country and currency from, let's say, people. And now we want to inner join currency on, and this works exactly the same. Let's define our aliases here. So P and C. We know that we need to use P dot country and C dot name. And we want the name column here to be from people. Surname is from people. Country is also from people. So it could also be C dot name instead of P dot country. And there we have C dot currency. I will just put a C dot name here just so that you can see that it's the same. End it with semicolon, and let's run it. Currency. And of course, the name of the table is not currency, but the name of the table is countries. Okay, and what we can see now is, let's maybe take a look at it with, I will just quickly change it to a left join. So with a left join, we have the 10th row here, but if we go to an inner join, we do not have the 10th row anymore. So because in the countries table, there is no entry for Denmark. Therefore, it's not matching, so no row is returned. But once again, if you are a careful observer or you are following it carefully, you might also notice that it's very simple also to go from this result set to actually the result set at the top. What you just need to do is say where, and now any column from the countries table, it can be c.currency, is not null. And essentially what is not null means is that, well, it's not null. So it's different than null, but actually don't use different than null. This is incorrect. On many DBMSs, this will produce incorrect results. Just stick to is not null in words. And now you can see that it's the exact same results. In fact, you can use here any table from any column from the currency table. You can also use c.name. What's more interesting is you can use c.area kilometers squared, and it's the same result, even though the column is not here. And this is because the selection of columns is really applied at the end of the query. So it first has all the results in memory, and then it will apply the selection of only on the columns that we want, usually. And therefore, this also works for us. So basically, even though this may seem, the inner join may seem a little bit different, it's not really that different than a left or a right join. It's just a left or right join with this added where clause. You can use both. Maybe it's inner join is a little bit easier to understand. Therefore, I will recommend that you stick to an inner join if you want to have this particular kind of logic in your application. We already covered a left join, a right join, and inner join. And what is left from the 4 types of joins is the full join. So let me remove this part right here. And now I'll copy this once again. And I'll here say full join. And now if you remember what a full join is, are the 3 parts. So it has the inner join part in the middle that returns only the matching rows. It has the left-hand side, so basically the rows which are not matching in the right table, and the rows from the right table which are not matching in the left table. And once again, matching is just the column values in the on condition. And I run this query, once again, here we can see exactly this part. So our inner join part are the 9 rows. Let's confirm that. If I run an inner join, I get these 9 rows. And then what we have is the rows from the people table that do not have a match in the countries table, and the rows from the countries table which do not have a match in the people table. So we have France with euro here, and we have Mr. Johnny Smith from Denmark. Both do not have countries or do not have entries in the other table. And now the order of tables here doesn't really matter. So you can have people here, you can have countries here. The order here doesn't really matter. So once again, from this full join, you can as well just add here a where condition. So basically you can say where p.name is not null and c.name is not null, and this will produce you the inner join results. But don't do it, it's just a good exercise that you can use so that you really understand how this is processed and what is the logic of applying the where condition right here. What may be a little bit interesting is, I hope that now you know what applying the where clause here does, but what happens if we now add an end condition here? So let's try to say end p.country equals, USA. And let's run this. And now we can see, in my opinion, a little mess here. Because what has happened is only the rows that have the country USA matched. So here we can see only here a match, and here a match. However, the other rows were still returned, right? So we still have here the names and all the names or the surnames of people, so basically all the people. And here we still have all the countries that were returned, but here we have many null values because only the ones where country is USA actually matched. And now I think it's a good occasion that we sort of go back a little bit to our previous episode where we dealt with the group bys, right? So there you remember that we were like grouping by and we had this count, and at some point in time I told you that a count star counts all the rows and the count with a particular column counts you all the rows where this column is not null. And I think currently we have many nulls here, therefore we can try to test that. Next to all the columns here, let's maybe return this one that is being repeated, right? Because the c.name is kind of being repeated after country, at least for USA in our case. Let's now add here a count star and let's say a count, I don't know, c.currency. So, and this would be also a good exercise to show you basically how it works together with a join, right? Spoiler alert, works exactly the same. Now we say group by, and we copy everything besides the aggregation function here. And then we run it. And what you can see here is basically, here we have a null, so we have a 0. Here we have a null, so we have a 0. Here we have a null, so we have a 0, right? So the only rows where we actually have a value is the rows where the currency is not null. So what might be interesting for you, for example, at least it was for me for a second, is that here we have 2, right? We have the euro and we have count and count currency of 2. And to investigate it, you have to sort of unwrap this query, right? So let's remove the group by statements and then everything should be obvious. It's because here we have the euro twice, right? So this group has 2 times euro. For this episode and for the joins, this is it. I would highly encourage you to go ahead and try writing a few queries yourself without looking at my screen. Just write a few left joins, write a few right joins, inner joins, full joins, just start adding some where clauses, like get a feel for how it works, because a practice here really makes perfect. I'm sure after you maybe write a dozen or 3 dozens of these joins, you will be much better, or you will get much more value from the next episodes to come, because we'll definitely be building on the knowledge that we have gathered, because once again, as I said, the select and joins are the very basics of SQL. But for now, I would like to thank you all for watching, and I will see you in the next episode.